All right, good afternoon. Welcome, everyone. Hope you've been having a great I.O. so far. I have at least. Hopefully that continues in the next 45 minutes. My name is Nate. I lead products for Kaggle, and I am super excited to share a little bit with you how Kaggle can be your home for finding trustworthy AI resources. I have some walkthroughs and demos, so I think we'll just jump straight in. Don't think it will surprise any of you to say that AI is moving fast. We have skyrocketing AI publications in all sorts of journals. We have the number of AI patents granted growing exponentially. The number of GitHub stars and so valuable GitHub projects is kind of going vertical. And the number of foundation models is doubling basically every year. All of this means we're continuing to increase the power and capabilities of our models. We're setting new baselines, it feels like, almost every week. And we're starting to saturate a lot of our benchmarks. So this has been a really exciting time for all of us in the data science and AI world. But it also means that there's been some problems, at least problems that I've been hearing from developers and AI practitioners in the ecosystem over the last year or so. So let's talk a bit about a couple of these. The first is that it's difficult to stay on top of the latest advances. It feels like a full-time job just keeping up with all the major model releases, let alone all the tools, libraries, projects, and other fun stuff being shared by the community. I feel like people feel that when they go to heads down and build something, they're like instantly losing touch with what's latest and greatest, and they feel like they have to pull themselves back out and grab a new model and start all over again. Second is that it's really hard to find the right resources for you to build on. There's just this explosion of new things being shared by everyone in the ecosystem. And so how are you supposed to know which one is actually the right one for your use case or your project? And last is, there's a high risk sometimes of getting this wrong. We're working in a lot of cases on the frontier of capabilities. And that means we're running up against the nascency of the technology in a lot of ways. And so as an ecosystem, we're still working to find the technologies, processes, methods for us to make sure that AI is being deployed to do the things we intend for it to do. And so I hear from Kagglers, from developers in the ecosystem, all over the place, questions like this swirling, and a lot of similar problems from the rest of the world. At Kaggle, we think that the community can help. And that by sharing, learning, discovering, and building together, we can solve a lot of these problems. And so let's just jump right into an example. Let's say that you're a developer working on, we'll move over to the demo machine, if that's all right. Yeah. Let's say you're a developer working on a use case that involves user-generated content. Maybe an application where your users can write something up, post it for the world to see. In the last year or so, you've started to notice some suspicious content that you suspect might be AI-generated that's really starting to drag down the quality of your user-generated content. And so you have a new use case. How can I detect what content that's posted to my application is actually human-generated and what's AI-generated? So this is a simple classification task. You have some ideas maybe on where to start, because you did an NLP project back in grad school. But you want to make sure you're building on the latest and greatest of resources and with the state-of-the-art approaches here. So where should you start? Well, one place that's actually surprising to find a really high density of amazing resources for you to get started on pretty much any use case is if you can find a relevant Kaggle competition. And so right here, we're looking at the Kaggle competitions page. If you scroll down, you can see all the active competitions that are available today. And you can see a bunch that have closed recently. But for today, we're going to try and find a competition in our space. So we'd really like to identify AI-generated content. So let's just try identify AI. And I see a bunch of options. These are all competitions that were run on Kaggle. This one's kind of interesting. Toxic comment classification challenge, if I could find toxic comments generated by AI. But this second one is actually maybe closer to the mark. Detect AI-generated text. Let's click on that one. By doing so, we're taken to the competition details page, where we can learn more about this specific challenge. And we can read that there were 4,000 teams competing, that it ended just 4 or 5 months ago, so it's actually pretty recent. And if we scroll down, we'll see that the challenge was to identify which essays written by students were AI generated or human generated. Now, our use case might be a little bit different, but we can take note of that afterwards and say, OK, maybe there's some things we'll have to change with my data set because my data set doesn't include essays, but there's probably some stuff for me to learn here. Scrolling down further, I can learn more about how we evaluated the success of all of the submissions that were submitted. So now I have an idea of an evaluation metric for my project. Here it was area under the ROC curve. And even further, I can see that this competition had efficiency prizes, meaning that if my use case has latency, cost, and compute efficiency as a very high requirement, I might be more interested in the submissions that won the efficiency prizes for this competition, not just the overall prizes. All right, so now that we've got a sense of what this competition was about, let's jump in and see what won. So we'll go over to the leaderboard, and we can see all of the top teams that won this competition, their scores, their profiles you can click on and check out all of their work. But what I want to call your attention to is that almost all of the top winners posted their solution publicly for the world. And so let's click on the winning solution. And when we do, we see a comprehensive write-up of how some of the world's best data scientists approached this problem just in the last couple months. And we can check it out and see maybe that if there's some ideas for how we would start. So first, they talk through their data mix, including listing out some of the specific data sets they use to train their model on. They share some other categories. They use proprietary LLMs, open source LLMs. They use LLM-generated text data sets to enrich their data mix. If we scroll down even further, there's some specific methods they actually use to augment their data to make sure they have the best possible fine-tuning data set for their use case. We could look up some of these or click on some of the links and very easily try and copy some of these methods. Below that, they list the models they use. So they use a Mistral model. They use Deberta. They tried a couple other options below. And they share some code about how they use QLoRa to fine-tune Mistral. All the way at the bottom, you'll find that they use an ensembling method at the end to try and get the best of all the models they trained for actually winning this competition, and that they shared their highest submission here, and all of their code is available on GitHub. And so in just 5 minutes, we've scrolled through and read the winning solution to this problem that thousands and thousands of people all competed on to figure out what would work best. And so this is just an enormous wealth of information resources that would help us pick up on our use case. And if we go back, we can see that there are lots of other solutions. We could click through all of those other ones, and by just spending an hour or more, I can really quickly get a survey of all of the state-of-the-art approaches for approaching an AI-generated text detection problem very easily. But let's say I don't have time to even read all these solutions, and I just want to grab a model that works pretty well and get started. Well, that's where the Models tab comes in. I can very easily just click on Models, and I get a list of all of the most popular models that were used in this competition. And right here, they're ranked by most usage. But I could also rank by which one actually had the best score at the end of the day. The scores for each of the models, the best public scores, are listed underneath. And if I click on any of them, so for instance, this BERT model, I get code examples using this model that were submitted to this competition, where I can very quickly just grab any of these and immediately get started creating a model of my own that detects AI-generated text. Let's check out the BERT model in more detail. Let's say I wasn't familiar with it. If I click on Model Details, I'm taken to the BERT model detail page, where I can learn a little bit more about this model. First, I get a description, which I can read a little bit more about exactly what this model does. It even includes a link to the original BERT paper, if you want to check that out and get into the details. It lists out metadata, like which frameworks it supports, that it's a text preprocessing model, that it's based on the transformer architecture, which language it supports. And it also has this usability score, which is a Kaggle-defined score that helps you understand the completeness and credibility of the resource that you find on Kaggle to make sure that you're building on something that's well-documented, well-maintained. If I scroll down further, I can see that BERT comes in lots of different variations. So they're all TensorFlow 2, but from the dropdown, I can see tons of different versions of the BERT model that are available. I can see that even this variation has multiple versions. If I click on that, I can select some of the previous versions. So it's very easy to find the exact variation for your use case that you might want. Maybe you only want uncased text, or maybe upper and lower case matters a lot for you, and you want to make sure that you actually use a cased model. Scrolling down, the model owners have made it very easy to find code to get started quickly that you can copy or create a new notebook and run very easily. And all the way at the bottom, we have an activity owner overview showing how popular this model is. And with 70,000 downloads in the last 30 days, we can see it's actually quite a popular model here and might be a very trustworthy resource for you to pick up and try on your own use case. OK, let's go back to the competition. And we see it's not just models that we have associated with this. We also have code. If we go over to the Code tab, you'll see all of the notebooks that were shared publicly associated with this competition. And some here are pinned at the top, so we can click on this and check out the efficiency leaderboard that was calculated with this notebook. And we have a few others that show how to train models or inference models using various frameworks in this exact use case. So let's check on this Keras NLP starter notebook. This seems like a really easy way for me to get started, if I already know Keras, on trying out an AI-generated text detection problem. We won't go through this whole notebook in detail, but if you scroll down, you could see that there's a lot of nice detail, code I can immediately grab and use, or I can just hit the copy and edit button up here and immediately jump into a Kaggle notebook environment and get started. There's also comment sections where people can raise issues or ask questions, and so you know that people are actually engaging around this resource in a meaningful way. One last thing I'd like to call your attention to is at the top, we can see which other resources on Kaggle this notebook is associated with. And so, for instance, the detect AI generated text proper trained dataset is calling out to me. Maybe there's some data in there that would be useful for me to include in my use case for detecting AI generated text. So let's click on that. All right. Now we have a page that looks very similar to that model details page, but this one is for a data set. We still have usability scores. We have a very helpful license that makes sure this is an MIT licensed data set, so I could actually use it for my business use case. Some might not. This is a data set that is expected to be updated weekly, which is nice because it lets us know that hopefully it's being well maintained. And if I scroll down after the data set description, I get this nice data explorer that lets me see what's really in this data set before I grab it to go use in my own use case. So there's 4 CSV files. It looks like they're pretty simple. A few columns, nice distribution of what kinds of data is available in here. And if I scroll down further, I've got some tags saying how others have used this data set. Looks like right now, most are using it for learning, but it does seem to be well documented, well maintained, and it's pretty clean. All of these are signals from the community, the many thousands of people who have used this data set that help you figure out if this is useful, a useful artifact for your own use case. OK, let's leave it there for now, and let's jump back over to the slides and talk a little more about all the resources that are available on Kaggle. And so what makes all this possible? Well, Kaggle is one of the largest communities for data science and AI in the world, with over 18 million lifetime members. And those users, through competitions, through building their own projects, through learning projects, have created one of the largest repositories of open assets for data science and machine learning in the entire world. Over 300,000 data sets, over 4,000 open models, and over 1 million code samples, all created through competitions and other projects that people are sharing there. It's a really exciting place. So let's just quickly hit through each of the resources available. We already talked about Kaggle datasets, 300,000 of them. These are well-versioned, licensed, hopefully well-maintained resources that you can easily find and download for your project. Nearly everyone in the data science ecosystem has grabbed a dataset from Kaggle in the past, and it's one of the most popular products that we have. We mentioned Kaggle Models. This is a new product that we launched last year that we're really excited about the community's uptake of. And so today, you can find not just a library of the world's most popular open models, but this year, we opened up community model sharing so that you can find models shared by anyone in the ecosystem, or you can share your own. We also have Kaggle notebooks, like we mentioned, over 1 million code samples shared across the years in all sorts of projects. And one thing I would really highlight about these is that we really prioritize reproducibility. So when you run on Notebook on Kaggle and you save that version, we take a snapshot of the environment it was running in, and we maintain an image with that environment over the years so that no matter how long it is till you come back to that resource, you should be able to open that notebook up and it run in the same environment it was running in earlier. No need to get stuck in pip hell with all the versions and compatibility issues. We also provide a free quota of GPU and TPU for these notebooks so that everything runs in the browser and you can do more advanced data science work very easily. And of course, everyone knows Kaggle competitions. We run 50 featured competitions every year, but we also run simulation competitions, research competitions, playground competitions for learning or just getting some practice in. And these are in all domains and across all industries where ML is applicable. We also have community competitions. So every year, thousands of competitions are being spun up by members of the community, just with projects that they're excited about or interested in, or problems that they really want to see solved. And so you can jump in and try any one of those, or you can come up with your problem and share them with the community as well. And lastly, we have solution write-ups, which is a new feature we launched last year and makes it really easy for you to find how the best data scientists in the world are solving these kinds of problems. I genuinely think this is one of the most powerful and data-rich educational resources in the entire AI ecosystem. And so hopefully it's obvious that Kaggle cares a lot about enabling the community to build and share valuable resources with one another. And we do that through a couple things. First is that we really prioritize accessibility and ease of use through things like usage examples and discussions where people can build an engaging community around their resources. We also want to make sure that your usage of these resources can remain compliant easily. And so we make it easy to share licenses, and we add citations to all the resources if you're working in an academic context. And lastly is there's nothing about community without collaboration. And so we want to incentivize people to share feedback, make updates, work on projects together, and we reward people for contributing to Kaggle and to resources through the Kaggle progression system, points, and our user rankings overall. So now that we know all the resources available in Kaggle, let's talk a little bit about how you can incorporate them into your workflow. As we already saw, all of the resources are available on our website, but sometimes it's nice to get things in a more programmatic interface. So we'll just do a quick rapid fire through some of those that we have. First is a Python client library called Kaggle Hub. It makes it really easy for you to push and pull Kaggle models directly into your workflow. Next, we've integrated deeply with Keras. So if you use Keras CV or Keras NLP, all of the models hosted there, their preset models, are hosted on Kaggle, and you can easily pull them directly into your code with Keras without even using Kaggle Hub or any other libraries with a single line of code. And I'm also very excited to share that just last week, we now make it super easy for you to push models you've created, fine-tuned open models or any other, directly to Kaggle, where you can store them there and share them with the community. We also have a Kaggle CLI if command line interfaces are more your thing. And so if you're interacting with our datasets, notebooks, or competitions products, it's really easy to grab and just pull data or push your submission to a competition directly from your environment. We've also been continuing to integrate deeply with other parts of the ecosystem that we know developers love. So we have a two-way sync with GitHub for all the code on Kaggle. If you make a change and push it to GitHub, you can easily sync that latest version directly to your Kaggle notebook. Or if you make a change in a Kaggle notebook, you can push that change directly to GitHub. This makes it really easy for you to share your valuable code projects with the world's largest AI community. And we know that people love using Colab to write and run their Python projects. And so we've been working really hard to integrate much more deeply with the Colab ecosystem. And we've recently launched features that allow you to open any project, any notebook in Kaggle directly into Colab. Or if you have a Colab that you're working on and you'd like to pull in, you can easily import it directly to Kaggle. But sometimes it's a little bit nicer to see these things live rather than just hear about them in slides. So I'm just going to go through some quick examples back in the demo machine to show you what it's like to use some of these features. All right. So here we're looking at Kaggle's notebook editor. So we previously looked at the notebook, a notebook in the viewer view before. But if you click copy and edit on any notebook in Kaggle, you jump straight into this browser-based editor environment that has a session running right now, which if I click, you'll see has GPU on. So like we mentioned, by simply clicking on this kebab menu and going down to accelerator, you can select your preferred accelerator for this environment. We offer an unlimited quota of CPU. We offer 30 hours of GPU for free, and that's either a P100 or 2 T4s if you prefer a multi-GPU workload, or you can select TPUs. All right, so let's jump in a little bit. First is we're gonna start working with Kaggle Hub, and I have some hidden cells above with just some imports and authentication. I will call out that in order to use the Kaggle API, for a lot of use cases, you will have to authenticate, which you can do by creating an API access token under the settings page on your Kaggle account. But just because I don't want to be copying and pasting credentials on a live demo, I've already taken care of that. There's a lot of methods to do authentication. Here, I've just used a simple login method that will prompt you for your username and that API token. Scrolling down, we can see our first example using Kaggle Hub, where we are, if you remember the BERT model we looked at earlier, we're downloading one of those variations of a BERT model directly with the model download method. And now doing this will immediately add the model to our input page over here on the side. And so I can see the BERT model is already added. For ease of time, I have run all these cells before. But actually, this download would work very quickly in the Kaggle environment, probably in a matter of just a couple seconds, because Kaggle caches all the most popular resources like datasets and models, and the notebook environment is directly integrated with that cache. And so even giant models like Llama 3, 70B, 8B can download in a matter of just a few minutes. All right. You can also download with Kaggle Hub a specific version of that model variation simply by appending the version number at the end here. One thing I should have mentioned earlier, actually, is you don't have to write the code here in the Kaggle environment in order to get access to these models in the input. You can simply upload them directly, or, because we're on Kaggle already, add input, hit models, and then search through any of these. And if we want to add Llama 3, we simply select which framework. Maybe we'll grab the 8B model and click and add. And just like that, a 16 gigabyte model is already added to our workspace, lightning fast. All right, now let's look at the Keras integration. So here I've imported Keras. I've imported Keras NLP. And with, again, a single line calling this Gemma causal LLM method from preset, we pass in the name of the Gemma model. In this case, it's Gemma 1.1, so version 1.1. It's an instruct model. It's the instruction tuned, not the base model version. And it's the 2 billion parameter version, which works quite well as a small model for pretty fast inference. And again, we see that's quickly added to our input over here, so we can easily manage the models in our workspace. Now that we have this here, we can actually run some generations. So we've run, what is the meaning of life? Meaning of life is a profound and multifaceted question that has captivated philosophers, et cetera, et cetera. I see also the meaning of life is subjective, which is rather unfortunate. I was kind of hoping to get a real definitive answer out of Gemma on this one. But we might also ask, what is Kaggle? And we get a super fast answer. Kaggle is a platform that provides collaborative environment for data science and machine learning communities. This looks pretty good. So just like that, I mean, I have done the absolute 101 level amount of code here, and I'm already playing with models super easily in Kaggle. All right, but it's not just open models that you can use. You can also use API-based models. So right here, I have imported Google's generative AI Python SDK. And I'm also using a utility from Kaggle Secrets, because Kaggle supports secrets through our add-ons tab. So if you click here, you can add your credentials for any other external services. And that means that you have a nice, secure place to store your authentication credentials. And you can share this notebook around without accidentally sharing API keys and the like. So a little bit of boilerplate code just to get our authenticated with Gemini API. But once we've done that, we're going to create a model. And we're going to select model name Gemini 1.5 Pro latest. And then we can just simply run some generate content calls. Tell me a story about a magic backpack. Tell me a story about a unicorn. Gemini Pro is a pretty powerful model. It'll take a few seconds. But in just a few lines of code here, we have made it very easy for you to work with the latest and greatest of Google's API-based models as well. For the sake of time, I won't read this story, but I'll assume it's a very cute story about a unicorn. All right, last thing I wanted to demo on this notebook is using the Kaggle CLI. I put it in a cell here, not in terminal or anything, just so it's easier for you to reproduce later. But very simply, you can add this quick command, Kaggle datasets download -d, and then the name of the owner, so the user or organization that owns the dataset, and then the name of the dataset right here. Here I'm downloading the Arena Hard dataset from LMSys, which is a dataset of very hard prompts used to benchmark LLMs in the chatbot arena. And so just like the others, running this will very quickly mount the dataset directly into my workspace, and I can easily get started with maybe fine-tuning my model, the Gemma model that we downloaded earlier, using some of these really advanced prompts. All right, that's all the code, but there are two other things I definitely wanted to show. First is we mentioned that we have been working much more closely with Colab to make it easier for you to move between those two environments. And so I just want to give you a quick sense of what that looks like. First is, let's say you were another user who had found this notebook, and you wanted to actually go run it in Colab because that's your preferred Python environment. Well, very simply, you can just go to File, Open in Colab. And when we do that, we get this nice warning which says, hey, not all of the things from this notebook will move over to the Colab environment. And this is actually great. Like, it's reminding us that my secrets aren't going to move over, and that GCP accounts aren't directly supported. And so I'm going to have to go set those back up in Colab secrets or some other method if I want to stay compatible. Let's continue through. And now, just like that, we're already running this notebook in Colab. And you could do this with any of the 1 million+ public notebooks on Kaggle. But you'll notice that this cell is new. We didn't have that in the previous notebook. And that's because the Kaggle environment and the notebook environment and the Colab environment aren't exactly the same. We don't store data the same way. We don't have exactly the same environment. But we try as hard as possible to smooth that path over by injecting this cell at the top of your notebook, which sets up new folders and makes it and starts to pull over all the data sources that you're depending on, so that this notebook can more likely run just all the way through very easily without you having to manage the differences between the two environments. It won't work for every single notebook because that's a pretty hard case, but this tends to work pretty well for a lot of the basic notebooks on Kaggle. And so you can just very simply run through the same exact examples here in Colab. Let's go back to our demo. And let's say now we had a Colab notebook that we actually wanted to bring into Kaggle. Well, very simply, I can go File, Import Notebook. And there's a few different ways I can do this. If I have the IPYNB file directly on my machine, I could simply drag it in here. If I have it stored in GitHub, I can link my GitHub account with my Kaggle account in Settings, and then I can very easily browse all my GitHub projects and pull in the notebooks that I need. For a Colab, you can take the link, the URL, and drop it in here and import that Colab over as long as you have permissions. Or you can actually link your Drive account or your Google account with your Kaggle account, and you can browse Drive for all of the IPYNB files you have access to and pull in any of them that you want into Google. I'm not going to click that just to not show all of the IPYNB files I have access to. All right, now the last thing to do, of course, is share it. We really want to encourage everyone to share their valuable resources with each other. And so it's as simple as going to share, public, and then save. And now our demo notebook is live for the Kaggle community to play around with. All right, let's head back over the slides and talk about why all this actually matters. I'm going to start with the question. The world runs on open source software. Why do we trust it? Now, it's rhetorical. I know you all have answers. But when I talk to people about this, one word pops out more than any other, which is transparency. Because the code is open, the world can see it, and we can audit it. But I think it's a little more than just transparency that makes the code that we use in open source trustable. And it's that transparency, the fact that everyone has access to the code, enables community. And just as a test of this principle, imagine two open source projects. You're looking for one. They both do about the same thing. One has one maintainer, last commit is 6 months ago, no issues in the issue log. The other has dozens of maintainers, has a very active issue log, and has thousands of forks and stars. Which one would you be more likely to build on? Now, if I told you like the features are exactly the same, functionality is exactly the same, you have not done an audit of the code at all. There's no principled technical reason why you are choosing the second one. But you have a good reason to, and it's that other people have been using this thing. And other people have been testing it and trying it out, and you have a better sense that the future for this project will be bright if there's a community around it. And so I really think it's that transparency enables community that builds trust in an open source project. The community can validate projects. They test them from every angle and every background. They have all different sorts of use cases, and by approaching a library or a project from very different angles, we build up a really good sense of, well, we've tried this enough times, it's probably robust and it probably works. The community can customize projects. So if they have specific needs, they can submit a PR. They can actually work on improving that project for their own use case. And that helps build trust. And lastly, the community can innovate. They can build on top of other open source projects. They can fork projects and take it a different direction if it starts to go the wrong way. And I think there's actually a lot to learn from this idea in the AI ecosystem. In particular, I think we should be learning from the open source ecosystem that building community around our models, community around our data sets, and community around the projects that we need to run the future on is really important for helping us build trust in this next generation of technology. And we see this every day on Kaggle. I mean, just take a Kaggle competition deconstructed as an example. A problem is posed. Thousands of people take different independent events at this problem. This is customizing, this is innovating, this is validating. And at the end, we have an objective ranking that bubbles the best solutions to the top. Those solutions are the best knowledge, the best resources, the best code, the best models for that particular problem. Basically, for 3 months in a Kaggle competition, we have the world's best collaborative research platform for that problem. And I think this is an interesting way to do science and to move the field forward. And it's one that Kaggle is very excited to continue to push forward into the AI ecosystem. So if there's one thing I would like you to take away from this talk, it's actually not the demos. I think they're really cool, and we worked really hard on them. So I hope you get to use them. But it's actually that community drives trust. And trust is really important for the next phase of artificial intelligence. We're still working hard to make sure this is a technology that we as a society and as a technical ecosystem can trust. And I believe that the community is the biggest part of the answer. OK, so let's just move to wrap up. We'll revisit our problems. difficult to stay on top of the latest advances. It's hard to find the right resources, and there can sometimes be a high risk of getting it wrong. Imagine a world where you're going at this alone, trying to figure out how to solve your use case. Or imagine a world where you are working alongside many hundreds or thousands of people in similar domains, sharing your data, sharing your code, sharing your methods, and figuring out the right way to approach things together. My guess is that by learning, discovering, building, and sharing together, we're going to be able to solve a lot of these problems a lot more easily. OK? So that means Kaggle is going to continue to build for you, if that resonated. And we want to be your home for the community-validated, trustworthy AI resources. Thank you for coming to this talk today. I hope you enjoy I/O, and I hope to see you on Kaggle.